Okay. Good morning or good afternoon, everyone. Thank you for joining us for today's webinar. We're thrilled to have two exceptional thought leaders with us today, whose work sits at the exciting intersection of technology, creativity, and the future of work. Dr. Huamin Wang and Dr. James O'Brien. Dr. Wang is Chief Scientist of Style3D and a renowned expert in computer graphics, 3D simulations, real-time fabric rendering. With his deep technical knowledge and experience, Dr. Wang has been instrumental in pioneering the tools that are reshaping the fashion industry today, like Style3D's groundbreaking iWish tool, among many, many others, which transforms 3D renders into photorealistic images, making it possible to personalize designs and bring concepts to life before a physical sample is ever produced. This is a core thing that we're doing here at the Style3D. His work's not only pushing the boundaries of what's possible in digital fashion, but also leading the charge in making the industry more efficient, sustainable, and creative. We're also honored to have Dr. James O'Brien, Professor of Computer Science at UC Berkeley, with us. Dr. O'Brien is the leading authority on AI, computer graphics, and forensics, having spent over 30 years researching and teaching at the forefront of these fields. His work has spanned everything from creating physics-based simulations in animation to developing advanced AI forensics that detect AI-generated content, effectively helping us distinguish between the real and the artificial, And in addition to his technical achievements, Dr. O'Brien has also been deeply engaged in discussions about the societal impact of AI, whether it's the way AI will transform industries like fashion or the broader implications for jobs, creativity, and the human endeavor. Today, they'll be sharing their insights into how AI and 3D technologies are transforming the fashion landscape, blurring the lines between virtual and physical creations, pushing the limits of creativity, and raising important questions about the future of work and design in an increasingly automated world. We'll be diving into these topics like photorealistic garment simulations, AI's impact on creativity, and the balance between innovation and authenticity. Please join me in welcoming Dr. Wang and Dr. O'Brien.
Thanks for the introduction.
Yeah, so yeah, that's fantastic. Yeah, I think I know Professor O'Brien for many years. I think almost 15 years, actually more than 15 years.
Wow,
I think
time flies.
Yeah. So I still remember like 2009, I finished my PhD and I joined Professor O'Brien's research lab in Berkeley. And I think back then, you told me there are two, I'm not sure if you still remember it, but you said there are two major research problems. One is about the simulation of digital garments, simulation of fabrics. Another problem is about the facial animation. And I'm still very glad today that I decided to do a simulation of digital garments, which is one of the reasons now I'm becoming involved with the fashion industry and joining Style3D eventually. But if you look backward, you see that both of those problems are somehow explored over the past 15 years. I mean, the facial animation is somehow solved by AI, in some sense already solved by AI. We have seen a lot of like deep fake tools, AI tools that can do, facial swapping.
Mm-hmm.
Digital garments, there's some research development about that, but on the other hand, we still see a lot of issues regarding the simulation of digital garments. What do you think? I mean, over the past 15 years regarding the technology, do you think that the simulation has somehow like this bottleneck that can't really push the realism to the extreme level, for fashion, that probably needs the help of AI?
Well, first of all, I'm so glad you remember the time that we worked together. I was very fortunate to work with you. It was you did some great work, really great work on cloth simulation, and now you just continue to really sort of just amazing stuff you guys are doing at Style3D. I think your question's a really interesting one, and I can think of sort of two factors I think that are big contributors to why our AI technology right now is better able to do facial animation than it is to able to do clothing animation. I think so. Two reasons. One is that while we're very sensitive to faces, if you look at how your face moves, it's really, in a lot of ways, it's much simpler than the way a cape or some clothing moves, right? You know, clothing, you have these large deformations and wrinkles traveling down, like a cape, for example, you have these waves traveling down the cape. Or if you've got clothing, it flips around. I've seen some work that you've done where you have like puffers, like with volume and thickness, right? These all kind of make the movement very complicated. And while very sensitive faces, and it's very hard to get them right when you're animating them, it's also the case that the movements are much simpler, right? You know, your face doesn't like fold over on itself. Even maybe a very elderly person that might have some nice, interesting wrinkles in their face. The movements are still, I think, much tamer compared to what you can get in cloth simulation. And I think the second issue that I think factors into it is that we have a lot of data about faces, right? I have, you know, I don't know, not hours, years of, you know, not me personally, but as a society, we have years of video of people talking, right? You know, just like if you added up all the time of faces on video talking, it's just enormous. And that data is often annotated with useful information, like for lip sync, like a transcript. And so I think it's a combination of, in some ways, being a slightly easier problem than the cloth simulation is, and also in some ways, well, in a large part, big factor is just the amount of good, high quality data we have. Right? We don't really have the same thing for cloth. Like if I wanted to find, you know, hours and hours of clothing with some annotations that tell me about the clothing, it's a little difficult. I guess the best I can do right now is to get, you know, full body motion where the person's wearing clothing, and maybe drive it with a skeleton. And actually, that's kind of interesting because we do have a lot of data on that, and that's one of the areas where some AI simulate techniques are actually doing a pretty good job with clothing. You know, just sort of driving on full body figures that are sort of a little bit remote from the camera. Seems to work pretty well so far. But for really complicated flowing motions, yeah, there's not so much great data for that, and also it's I think a harder problem.
Yeah, I think overall, even if we, you know, decided to do AI research related to fashion, I think one of the limitations we found is the data. Is where do we also find high quality data? You know, that's also a big problem. We also did a little bit of pattern related, you know, sewing pattern related research, and we found that how do we get high quality data is a huge issue. Yeah, so you know, about the realism, because I think we did some work regarding the you know, how do we measure fabric material properties?
Yeah.
You know, I'm pretty sure you remember that. Yeah,
it's one of my favorite papers. It was great work.
Of course, yeah. And I went to SIGGRAPH this year, and we had a bird of feather event. We have people related to fashion coming and talk about what would be the most important problem, you know, for 3D. I think one of the big problems that we mentioned is how do we make sure the, you know, the simulation is realistic enough, and somehow, you know, even though, you know, we spent so many years doing this type of research, we found that it's a very difficult problem. So I'm a little bit somehow I'm a little bit lost, or maybe I shouldn't say that, but yeah, it seems to be a very difficult problem. Like from your perspective, what do you think? Like you know, what would be the major step that we could do in terms of research to help make the simulation more realistic for digital garments?
So, you know, so you mentioned the paper that you did when you were at Berkeley on measuring the material properties of cloth. And one of the things that I really liked about that paper, and that I think is still relevant today, very relevant today, actually, even more relevant maybe than it used to be, is that you know, you can try to measure properties directly. Like you can take a piece of cloth and put it in a device, and you can stretch it and then measure the stress to strain ratio and how it changes as you and that gives you a direct measurement of some property. The approach that I liked in your paper was that rather than doing that, you took a sample of cloth and you put it under some general loading conditions that you varied. And rather than trying to directly measure property, you made observations about saying, if I put this much weight on the cloth, how does it behave? And then you did the inverse, essentially the inverse simulation, the search to find the parameters that cause the simulation to match what was observed, right? It's an indirect way of getting the getting the material parameters. Rather than trying to measure it directly, you say, well, I saw it behave like this. What kind of parameters do I need that will make my simulation behave like that also? And at the time, that work was done, there was very limited, there was no PyTorch, there was no TensorFlow, right? The tools for doing this kind of thing were kind of limited. Also, the optimization is expensive, and the machines were, 15 years ago, much slower than they are today.
Yeah,
but I think
remember
that general
you had a computer caster to do it.
Yep. Yeah, and now you can do it on a laptop.
But
the approach, I think, is the right one, and you can actually see how it generalizes, because in that context, you said we have a simulation. Let's find the parameters of the simulation that make it match what we observed in reality. There's a lot of interesting work that's coming out now that not necessarily in graphics, but also in other fields, like solving PDEs, like for designing antennas and that sort of thing, where you have a similar problem. You have a simulation that you can use that, at least in theory, is correct, Maxwell's equation, or in fluids, Navier-Stokes, or whatever. But of course, we know that there's always some difference between the real world, these models that we have, and the real world. In fact, you can sort of think of the Navier-Stokes equations or Maxwell's equations as a human being fitting a function to observations. And so one of the things that's kind of nice, very interesting right now, simulation techniques that use AI. And you start off by training something using what's called PIN, physics-informed neural networks, where it trains a network on the physics, not on examples, but on the physics themselves. And then you get something that's actually able to do forward simulation. But then you can refine that model with observations. And in the end, at least, this is still, a new area. But the idea is that in the end, you'll end up with a model that is not just based on the approximation of the Navier-Stokes equations or the Maxwell's equations or whatever it is that you're looking at, but instead actually more closely matches the actual physical object that you're modeling. And if you think about it, that's really kind of the approach that you were taking in your work 15 years ago. But now the technology we have to do that kind of work is better, right? Now we have great optimization tools. We have the ability to run much more massive scale simulations and optimizations than we did previously. But I think that's probably the solution there, right? The cloth is so complicated when you think about how it behaves with all these woven or knit or whichever kind of cloth it is, but you have these basically very small scale structure that again gives us a large scale behavior. And so I think that trying to build models that capture that effect, the idea of a continuum model is that whatever you're modeling is below the scale you're modeling is just homogeneous and continuous, but that's not true with cloth. So I think that these types of fitting models, where you take a neural network, a model, and you fit it to your observed data, and that becomes your simulation, or at least a core part of your simulation, like your constitutive model. I think that makes a lot of sense, and I think it's an approach that's going to continue to work.
I think you're basically describing our SIGGRAPH paper this year.
Yeah, exactly.
Okay. Anyway, I do have a few more questions, but I think I will leave this to Matt. I think Matt also has questions that you want to ask.
Sure. Just give me one quick moment while I was so engaged in this in that discussion, I moved away from my list of prepared questions. Dr. O'Brien, I read you sent us some reference materials ahead of this in preparation for this webinar, and you wrote a couple articles that I read, and in them you describe utopian and dystopian futures shaped by AI. I'd like to dig into this a little bit, because I know this is kind of like a topic of passion for you. Do you see currently a kind of intermediary step? Right now, you've defined two kind of possible outcomes. One where all of the resources are repped by the wealthy, those who are in power, and those who don't have access to those and don't have necessarily desirable jobs. Do you see sort of like an intermediary step in the future where these AI technologies are more empowering, enabling tools than they are kind of leading towards this binary future of everyone has, very few have everything and most people have access to nothing?
Yeah, I mean, it's a complicated issue. on one hand, AI technology allows an individual to become much more productive, right? I can, if I want to work on a project, I can define the project, recruit some graduate students, and get them working on the project. But I'm also finding more that AI technology can be used to, for example, generate the code that I previously might have hired an undergraduate to develop. And so there is, you can't really get away from it. It is true that AI is replacing people or taking jobs, right? You have roles where someone was hired, and now that role can be performed automatically. So there's a good side and a bad side to this, right? People become more productive, you can get more done. The negative side is that a lot of jobs, particularly the jobs that were less sophisticated and less complicated, are becoming more and more addressable by AI technology. We also, most people, including myself, or many people, not most, I don't know if it's most or not, but many people believe that this AI technology is going to continue to advance until they get to the point where it's really comparable to, even a senior PhD experienced researcher, what they'd be able to do. And as that happens, I think, we are going to have a situation where jobs start to sort of go away. And, again, that's sort of the long-term view. The short-term view is that for people who are able to use the AI tools, there's a lot of productivity gains. And I think that this AI technology is a little different than previous technology. And the example I like to give is like a factory. In the past, if I had a factory and I automated it with an assembly line process, or I added robotic devices to it, I still needed people to run I still needed people, right? I needed people to maintain the robots and monitor them, make sure that they don't, pick up the car door and put it in the wrong place or whatever. And so effectively at that point, nobody was being replaced. It was at least not the sense that I didn't need people. You still needed people to run the factory. At some point, we'll get to a transition point, because 0 is different than every other number, where we need 0 people to run the factory, right? If the factory is able to monitor itself, it's able to have a system that's able to observe and look at exceptions and problems that occur and troubleshoot them on its own, then at some point you need 0 people. And that's a very different situation than needing a finite number of people, because if I need some number of people and I want to double my factory, well, I need to hire twice as many people, or I need to hire more people. But if my factory requires 0 people and I want to expand it, now I just need resources to build and buy more stuff, right? I don't need to hire people. And that really changes the way the dynamics of our economy will work, right? Right now, there's a fundamental premise that value is created by people working. And the way we fund our government in the US is that we tax income. So when somebody does some work, they earn some money. At least in theory, that money is representative of the value they created in some way. And the government taxes that income and then uses that money to do all the things the government needs to do. If we go into a situation where we have fewer and fewer people being employed, that means that the base of income that we'll be taxing is going to shrink. While simultaneously, the people who aren't employed, I don't think it's the idea of just saying, oh, too bad, live on the streets and let them eat cake. It doesn't make any sense. Which means that we're going to need more resources to support people like that. We're going to need support programs to replace. And in the past, when people talked about it, there was always this problem. The value would be created by somebody working. And so if you tax that to then give support to people who aren't working, the people who are working get a little bit upset. They're working and they're being taxed to pay for the people who aren't working. But as we look towards the future, where a lot of the work might be done by automated systems, taxing the work of an automated system doesn't need a house to live in. An automated system doesn't need to have a car, it doesn't need to go out to dinner in the evening. It doesn't need money. It just needs to be kept in running order. And so taxing automated systems and using that money to provide support, I think, is a very different model than what we've been able to do in the past. And quite frankly, I think that's the direction we have to go. Because when you think about your favorite science fiction show, in Star Trek, it's kind of this beautiful place. Everybody's sort of, there's food, there's water, everybody lives in beautiful cities. And then there's like Mad Max, where they're running around the desert shooting each other and crashing cars and stuff, right? If we don't find a way to provide for people in our society that don't have jobs, then we're going to end up with the Mad Max scenario. I think we can end up with the Star Trek scenario, the good scenario, because if automated, think about it, if automated systems are producing a lot of value, then that value can be shared in a reasonable way, then there's enough to go around. And actually, I think still enough for the people who, own the systems and stuff. They can still be wealthy. They can still be, billionaires or whatever. But that doesn't mean that, just because somebody's wealthy doesn't mean that everybody else has to be dirt poor, right? There's actually, I think, enough to go around. And as these automated systems take jobs, that will be the negative side, but they'll also be now doing automated work producing value essentially for free. And that's a positive thing. So if we can figure out how to make it work politically and economically, and there's a lot of details, obviously, it's not a simple thing, but I do think that we could move in a direction that will be good for society. But as long as we cling to the idea that, income is the only way the government gets funding, and also as long as individuals are told you only have value if you have a job that produces income, I think that's going to be very unfortunate. And the truth is, many people, lots of people, that their work is something, when you're talking to researchers, it gets a little confusing because our work and our personal identity kind of get, what do you do when you go home? You read papers, right? It's kind of like takes over your whole life. But for a lot of people, you go home and you leave your job there and you come home to your work. There's lots of ways to have a rich life that don't necessarily involve having a 9-to-5 job that you're getting paid for. The question is, how do we get from here to there? That, I think it's a difficult question.
Yeah, and it seems like it may be some amount of time off, right? The timeline between now and that eventual end game may be in years, could be decades, right? We're not really sure. There's going to be some sort of transitional period in the meantime. What's your feeling on how to kind of prepare and to help people who are in the industry, especially in fashion right now, who are kind of competing with these notions? What's your advice to either embracing AI and learning to manage the beast, or to maintain your artistic integrity and continue to manually create all of your designs and do things the way that they've kind of always been done, or like I said, managing what is the technology that we have in our hands today?
Well, I think you can, you mentioned this idea of the integrity of your own design, your own vision for, if you're designing clothing, you've got some idea, like and I think you can do both, right? So writing is think about writing using a large language model to help you write. So I do this now. If I write something, I'll write a first draft of it, and then I'll run it through a large language model to get some feedback. Quite often it does things I don't like. It will it writes things in sort of using, wording that doesn't sound like me. And then I change it back, or I change it to a third way that, I look at what it did, I see the problem it found, and I say, okay, well, I'm going to address it a different way. So at the end of the day, the writing's still me. It's still my writing, still my words, still my ideas, still, if somebody picks it up and reads it, they say, this sounds like James, right? It doesn't sound like, random large language model, chat GPT or whatever. And I think that can be, in any field, right? If you're designing clothing, you could use some automated tool and just say, here, do the work for me. But presumably you have some idea of what you want it to be. So again, you can have an iteration loop that includes the AI technology as a tool rather than a replacement for what you're going to do. And the best advice I could say for people that are, the first part of your question is, well, these tools are coming out. And if you learn to use the tools and you become adept with them, then you'll be one of the people whose effort gets multiplied by these tools. If you ignore the tools and you persist in just doing everything by hand, in some cases you'll be fine, right? If you're a famous artist or a famous designer, you're fine. But if you're just sort of like a regular person who has a nice job designing clothing and you ignore those tools, I think then it'll just be a matter of time before you find yourself replaced. On the other hand, if you become good with the tools, if you understand how to use them, if you integrate them into your workflow, particularly if you're able to integrate them into your workflow, that doesn't compromise your vision, right? If you're able to, integrate these tools into your workflow and find a way to work with them to get what you want, not just to get what random thing they might produce based on some prompt. I think you're going to see that people who are able to do that are the ones who are going to continue to be successful. again, long term, who knows what's going to happen in terms of people having jobs, but certainly I think in the short to medium term, understanding and embracing these tools, I think is a better strategy than sort of being rejecting and hoping they go away, because they're not going to go away.
Yeah, no, thank you for the answer. Okay, so a quick follow-up. Both of you have contributed to making complex technology accessible, whether through advanced fabric simulation or AI tools like iWish, which Dr. Wang, we can talk about. How do you see 3D tools and 3D design tools and AI making fashion more accessible, kind of in the same thread, more accessible to smaller brands or individuals? Right now, there's lots of individuals who are kind of getting access to this technology and are able to force multiply their own efforts and kind of from a very small team do lots of very impressive design work and even get your product out to market. Yeah, sorry, Dr. Wang, how do you see those design tools making them more accessible?
I think it's slowly changing the landscape right now, but it will take some time. That's my quick answer to this.
Okay.
But I think, yeah, go ahead, James. Yeah.
No, go ahead.
Yeah, but I think one question, like my biggest question for me right now is like when what would be the killer app for like AI and these AI tools? I mean, I have seen a lot of people like developing these tools for other industries, including fashion. A lot of time those applications are mainly for reducing the cost, like replacing some of the existing methods. For example, the iWish tools that we're developing is to replace photo shooting for fashion business, right? But then in that case, you would have to compare the AI tools with traditional way of doing photoshopping in terms of the cost, in terms of the time. But then you also have to make sure, eventually you have to convince the business that this is better compared with the traditional way. Alternatively, I'm thinking that, in the future, could that be some AI applications that not just to reduce the cost, but also to increase sales? I mean, for the business, that's even more important because if you're able to sell more, you're able to make more money. But I haven't seen such application yet, but this is something that important that we should explore, not just to reduce the cost, not just to replace existing methods, ways, but to do something new, creative.
Understood. Thank you. Dr. O'Brien, I'll give you a chance to chime in if you have comments.
Sure. I think so. One thing I think is kind of interesting is what can you do that's different what could you do that you can't do today that you would be able to do? And one of them I think is the idea of custom design clothing. So one question you might ask yourself when if I order pants, I have to have them hemmed, or a shirt, you have to have the sleeves hemmed or whatever. So you have an alteration done. But if you look, you'll find it's very difficult to find some place where you can send them your measurements online and they send you back the altered clothing. And the reason for that makes a lot of sense, because if they did that and you return it, what are they going to do with this altered clothing that now you wanted to return? And since you weren't able to hold it in your hands physically, most people want to have the ability to return something. And so even for simple customization, as simple as just adjusting the length of pants, it doesn't quite make sense to offer that kind of a service right now. And if you look at sort of even more sort of ambitious idea of saying, well, you can design the clothing yourself, pick the material you like, pick the cut you like, adjust the cut how you want, all these little, basically, custom design clothing just for you. And you can think of many axes where you could be designing, doing the customization, everything from fit to material to overall, just lots of different directions. But it would be kind of a disaster right now because everything would get returned and you'd end up with this pile of returned clothing that nobody wants because it's all weird customizations. If you have this kind of simulation technology that has very good fidelity and that is really accurate, it actually shows you what it has good fidelity to what the real object would look like. And you have models of the body that allow you to be accurate towards a particular, with respect to a particular user, shopper, whatever you want to call them, person who wants to buy some clothing, suddenly these customization techniques start to make sense, right? If you're able to see how it's going to look and you trust that visualization, you might be willing to pay for something that you can't return because you have high confidence in what you saw, and that would totally change things. Couple this to the fact that, as we have, one of the problems with doing custom clothing is that it's difficult, right? We have cutting machines that can cut the patterns. I give you a pattern, I can cut the pieces by the hundreds, right? These amazing machines, they're like the length of a football field with, stacks of 200 layers of cloth, and they just use a saw cutting through them to cut lots and lots of pieces all at once, and they still get sewed together by hand. And that's because manipulating clothing is very difficult, right? Robots are great at manipulating rigid objects, like picking up a screw and putting it over here, or picking up a block and inserting into that, right? Robots are great at that. But picking up a piece of cloth and getting it lined up and sewing together, that's quite difficult. But if you look what's happening now with these general purpose robots, there is work right now. Peter Abil at Berkeley, for example, collaborated with us a while ago, taking our cloth simulation and using it to do planning inside for robot planning to pick up and fold clothing. It was very slow. Like, when you watch the video, it has to be played back at 5 times speed because it was, it just took a long time for it to figure out what each step was. But that's going to get better. It's going to get better. It's going to be faster. And so I see the possibility in the future of systems that can design, robotic systems that can cut and sew and completely build clothing autonomously, based on unique specific patterns, custom designs. And the simulation gives you the ability to visualize what that looks like. This seems to me like a whole new direction that today doesn't exist. Right now, custom clothing is for people who can afford to hire a tailor to build the clothing especially for them. It's reserved for wedding dresses and tuxedos and special occasions, right? But imagine if, every garment of yours could be custom made for you the way you want, and it didn't really cost anything more than just buying it off the shelf would. That would be something new.
Oh, awesome. Yeah. Thank you. Professor Wang, Dr. Wang, do you have any other additional questions you wanted to pose to Dr. O'Brien, or did you want me to continue?
I just have a very quick follow-up question, because you Professor O'Brien, you mentioned like a virtual fitting, basically, virtual try-on, right? So you have a way to see what you look like with the garments. I think this is going to be one of the biggest challenge, but also the biggest application for the business. I think everybody talk about this like almost or maybe even for more than 10 years. But I haven't seen a lot of progress in that direction, like or even recently. Like realistically, when do you think this is going to happen eventually? 10 years or maybe 20 years? How long this is going to take?
Yeah, that's a good question. I mean, in some ways the technology is there, right? Like, I'll use your simulation as an example. They're great simulations. I mean, I've seen the results that come out of them, and they're really impressive. I think if you had an accurate model of the body, I think you could actually simulate with pretty good fidelity what the garment's going to look like before it even exists. The startup company that I was with a few years ago, Avometric, same thing. We were able to not all the effects that you guys are able to do now, but we could do quite realistic simulations showing what something looked like. In fact, we were using the constitutive model that you were talking about earlier that you developed when you were at Berkeley. But what we found out was that two problems with doing that. One is that the merchants that sell clothing don't have the patterns, right? Think about Bloomingdale's or Macy's or some department store. All the stuff they're selling was designed by some third party, manufactured by some third party, and they're just selling it. They don't have all this information about it, like a pattern file. So it's hard for them to do a simulation. Users also don't have models of their body, and people aren't very comfortable scanning systems. but that's changing a little bit, right? We have AI techniques that are able to infer pattern files. Not, still not so great, still, or I shouldn't say not so great, still it's a hard problem, still, being refined and getting better. But that, being able to build a pattern from looking at an image of something or somebody wearing a garment. And we have techniques now that can do pretty good body models just from photographs or video. And so I think there is progress there. I think it's still a hard problem because you on one hand, you don't, both, not because of the simulation technology or because of the body modeling technology, but because of the data issue, right? The pattern data doesn't exist at the point of sale and the customer doesn't have body data. I think that those things I think both of those can change. There's also try-on techniques that get away from simulation and just use AI to put things together. And these methods aren't going to tell you about fit, right? Because like if I can use a AI system now, a generative model, and I can have a photograph of a model wearing a red shirt, and I want to see how the red shirt looks on me. And now I can put these into an AI system, and it'll generate a new image of me wearing the red shirt. But there's no size information, right? It just said there's a red shirt. I'm going to put it on James, and we're just going to assume that it fits him. That's great for this idea of style, right? I can say, do I look good in red shirts? Or maybe I should have a different kind of shirt or a different color. But that still leaves the question about fit unanswered. And so if the AI systems are able to either, one of two things, either we get the data somehow, whether through AI inference or because of better, data pipelines, get the data to the point of sale to model the garment, get the user comfortable, or use video or use some technique to get the body data, then that's one way to do fit-based try-on. The other is that we might find a way to build an AI system that's able to, look at one person wearing a shirt, figure out what the size is of that person relative to another person, and figure out how the shirt would fit, including the fit aspect. So like if I try tying on a kid size shirt, it'll be tight and not work. And if a kid tries, the extra large, it'll look like a 10 on them. Right now, the AI systems that I try clothing, they can't get those fitting effects. But that doesn't, there's nothing that says that's an inherent problem that's unsolvable. It might change. And we also might get better about using the simulation technology at the point of sale. But it's not an easy problem.
It's definitely not. Okay. Yeah, Matt, I will leave this to you.
Okay. I actually I'm calling an audible because I've had some conversations with my former colleagues who used to work at Avometric, and this is a question that's been kind of burning in my mind. Generally, when we scan, you touched on this, people are not very comfortable with scanning techniques right now. My understanding is that generally this is because people are just not comfortable seeing themselves after the scan. And this also creates another issue, which is that once you have somebody's individual body in an environment and saying, okay, I've got you, and I'm going to show you this garment of you in this garment as fitted perfectly, the expectation becomes different from an off-the-rack sizing scheme where it's small, medium, large, extra large. The expectation of fit, the threshold becomes much narrower. You expect the fit to be very, very good. Otherwise, you might actually, maybe my question is this: what is the impact of this reluctance to do body scanning and the inability to trust the visual result, even if they're 100% accurate, even if they're correct? Your perception of that fit may be off, or your preferences may be off. What do you think are the impacts of that?
So, I mean, the scanning is kind of interesting. So, you mentioned Avometric. Back, early on, we did a test where we, with Old Navy, where we put a scanning booth in one of their stores, next to the changing room, and and we set it up, we thought, in a very simple way. There was an iPad inside; it would guide you through how to stand, and it would scan you. And couple things we found. First of all, most people were very uncomfortable with it. Does this see through my clothing? Does this, am I going to be naked on the internet? What's going to happen? What does this do? I don't know what it is. It's new. It's unfamiliar. And it's you know, it's an unfamiliar thing that's asking for very personal access, right? It wants to scan you, but you don't know what it is. And so you can see how people wouldn't that are not, you know, like, if you go to someone at SIGGRAPH, they know all about scanning. They might say, no, big deal. But your typical human being who's shopping doesn't know about scanners and laser scanners, and it's unfamiliar. The other thing was that people had trouble following the directions, right? Yeah, I thought the directions were very clear. We made them as clear as we could. There was, an iPad that would have little dot, sort of walk you through it, and you would get people facing the wrong way, people putting, thinking it was an airport scanner, and just like everything all over the place. So lots of problems with that. There's also some issues which we ran into, which is that when you get scanned, you're in clothing. Like even if you're just wearing underwear, for example, your underwear still compresses and shapes you, right? Particularly like a woman with a bra, for example, right? That the whole intent of that clothing is to provide shape and support, right? And so if you wanted to get a model of someone's body, then that interferes with getting a good model of what their body looks like. You also have the problem that people are not rigid; we're squishy. And so if I scan you and when you're standing up straight, but then you put on a shirt and you slouch a bit, right? There's all this stuff that has to happen for that body model to be useful. It's not just about like a rigid object, like I scanned a statue. You have to be able to account for all these things. How do the clothing shape the person? How will different clothing shape them differently? How will their body shape change as their posture changes as they stand up? You even have, there's also an issue about accuracy, and which is, just taking a breath significantly changes the size of your body. And you've probably seen a movie or a television show where there's kind of like a joke where somebody squeezes into some clothing and they say they can't breathe, right? They joke about how they can't breathe because if they do, the thing's going to split open, right? Well, the reason for that is that when you breathe, your body changes its shape and size. And that's important, right? If I put something on, it needs to look good when I exhale. And when I inhale, it can't burst at the seams. And so when you think about doing virtual fit, try on for fitting, not just for style, you see that you actually need a very complicated model, right? It has to, capture, soft tissue deformation, interaction with the clothing, movement, as the person changes their posture, breathing, all this stuff has to be accounted for. And then on top of it all, you have the issue that, people aren't even putting in breathing aside, we're not static, right? Sometimes I put on a little extra weight, in the holidays, and then when the holidays are over, I try to lose it, right? We change size because we lose and gain weight. So there are all these things that have to be taken into account if you want to have accurate fit information. We do that naturally when we try on clothing, because when you try on clothing, you breathe, you turn around, if you're going to wear like a men's jacket, you might kind of move your shoulders and see if you have room, right? You do all these things to test it out. And if we want to do virtual fitting, we need to be able to do those same things or somehow provide that same information. Difficult. I don't think it's impossible, but you can see why it's not an easy problem.
No, I'm definitely a different size before and after my lunch. I can attest to that. Thank you for that answer.
There's one thing I want to add to that is like people have different opinions regarding the fitting. Like some people, for example, for the same pants, like some people want this to be very tight, for example, and some people wants to be pretty loose. So, it's not like a scientific measurement you could have to describe fitting, because people may have different preference.
Yeah. They could even have a different preference depending on context, right? Like maybe the clothing I wear when I go to work and the clothing when I go out to, the nightclub, and, probably very different ideas about how I want my clothing to fit.
Yeah. Okay. I believe that gets me through the majority of my questions. What I'm going to do is, while we wait here, I'll just continue to open up the questions to our audience in Q&A. We only have currently one question. It's actually more of a statement saying it would be great if you could create a mocap suit for simulating clothes using AI. Perhaps you could wear it beneath the actual garments you want to animate. perhaps that'd be something that could help in understanding the problem of breath and posture and the things that you were just mentioning, Dr. O'Brien.
Yeah. So I mean, this is one of the things I'm excited about is the, you know, quote mocap technology that just uses a single or multiple video feeds with no markers, markerless video motion capture. This technology has come a very long way in the last couple of years, right? I've seen examples that are very impressive. You know, crowds of people, you know, like a big crowd of people dancing, and systems able to extract skeletons for you know, each of them, even though they're kind of small in the frame. There's a related problem to this, which is inferring the body shape, right? If I do motion capture, I've got your pose, your positioning of yourself. There's this extra part about wanting to get the shape of your body, but the techniques for doing this from video are getting much better than they used to be, to the point where you can actually do at this point do a pretty good job inferring what someone's body looks like under their clothing. Not as accurate as if they stood in a laser scanner, but still pretty good. And that technology is going to continue to improve. Yeah, I'm not sure.
Old Metrics has some sort of solution where they're measuring just a couple, like I think neck, or there's actually a few that don't even ask for any measurement. They just ask for demographic information. So how tall are you? What is a size that you generally wear, and what size shoe are you? Something like that. And from that, it seems like they're able to obtain really robust information about body dimension. It seems almost impossible.
Yeah. So I mean, so the techniques that do it based on video, you know, they're trying to infer what you look like underneath, and they do need some bit of information to fix the absolute scale, like your height, right? You know, you know the joke, right? You know, somebody could be this big and very close to you, or they could be regular size and at a distance, right? So if you're doing these video-based things, you generally need to have some notion of height, or you need to have some sort of a calibrated system with multiple views so that you can infer, you know, that you can peg down that absolute scale factor. There are systems that are kind of interesting. TrueFit is one of them, where what they do is they don't actually know anything about what your body shape is directly, but they use correlation with other shoppers. And so they find, if you buy something and you say this size fits me and I'm happy with it, then they find other people essentially who bought the same thing. And then when you want to buy something new, they look to see what those other people bought, and that's what they suggest to you. I mean, it's a little more complicated than that, obviously, but that's kind of the idea, right? It's they're figuring out what to suggest without modeling on your body. They're figuring it out based on sort of just using the wisdom of the crowd, or whatever you want to call it. And I think both approaches are pretty interesting. The techniques for doing it from single video. I mean, if you want, you can sort of use humans as sort of a proof of concept or a proof of existence, right? If I take a photograph of somebody and I hand it to a skilled someone who's familiar with anatomy, someone who understands the human body, then they can look at the picture and figure out the person's measurements from the photo. If a person can do it, then eventually we'll be able to have machines that do it.
Yeah, we do have a new question from our audience. Actually, a couple of them just came in. First one: are you familiar with the successful methods that adapt the fit or sewing pattern based on different poses or intended activity? Of course, you can do the simulation and try out the fit with given motion, but how do you then adapt the garment in the case of too much stretch? And actually, this is, I believe, work that Dr. Wang has a little bit of insight into as well. So I'll open this up to both of you.
We did some sewing pattern optimization work before. We did not do this for different poses, but we do this for different bodies, like a grading, like automatic grading system. But I think the idea is the same. Like once you have the different motions, maybe you have some objective, which, for example, you try to reduce the stretch. Then based on this objective, you can optimize the sewing pattern boundary with some constraints. For example, you want to keep the line straight, for example. But I think probably based on some optimization, this could be done for pattern adjustment.
Yeah, I agree. I think it's a great idea. It's, and definitely technically feasible. You can actually, I was talking about custom design clothing. You can totally see how that sort of thing would be an important part of it, right? You know, if I'm selling you a custom tuxedo or running pants or whatever, either way, it has to fit for your range of motion.
Yeah. Okay. I believe that gets us to the end of our questions. I'll just say from a personal note, as somebody who's been kind of in the 3D fashion world for the past almost 20 years now, it's great to see things that I used to get asked about all the time that at the time were science fiction are actually now coming true. Yeah, ask questions like, can I just take a picture and will it make this garment for me? And at the time, it seemed completely absurd and like, you know, why would you even consider that as an option? Whereas it's totally conceivable now to see that as a possible thing that we're going to do in the not so distant future. So this is really, really exciting, and it's been a wonderful time talking to both of you. Thank you both for sharing your expertise with myself and with our audience. Thank you both for your time. And again, I'll just leave it up if you have any other closing statements, but other than that, thank you both.
Thank you.
Yeah, thank you. No particular clothing statement, but thanks for having me on the show. This was it was fun. It was interesting. Yeah, thanks a lot.
Thank you.
Great
Looking
questions.
forward to, hopefully there'll be more of these. So thanks again.
Sounds good.
Thank you.
Thanks everybody. That concludes our webinar for today. Have a great day. Bye-bye.
Bye.
Bye.
Yeah.